An underground flexible coupling is specifically designed for use with 3-inch polyvinyl chloride, commonly known as PVC, directly below a meter pan. It addresses issues related to ground movement. This type of coupling is engineered to absorb ground shifts. It incorporates a 90-degree sweep as part of its assembly. This allows for flexibility and prevents stress on the piping system due to soil settling, frost heave, or even minor seismic activity. The primary function of this coupling is to connect two sections of pipe when they are not perfectly aligned. It is typically made from a flexible material. Common materials used include rubber or ethylene propylene diene monomer, often abbreviated as EPDM. These materials provide the necessary flexibility to absorb movement without compromising the integrity of the pipe connection. There are several benefits to using an underground flexible coupling. Firstly, it absorbs ground shifts. Soil is not a static entity and it is subject to movement due to various factors. These factors can include soil settling, which occurs naturally over time as the soil compacts. Frost heave is also an important factor to consider, especially in regions with cold climates. When water in the soil freezes, it expands and can cause the ground to lift. Then there are earthquakes. Even minor seismic events can cause ground movement. The flexible coupling is designed to absorb these shifts. This prevents the pipe from breaking or leaking. Secondly, the coupling allows for misalignment. In many piping systems, it is challenging to ensure that all pipe sections are perfectly aligned. This misalignment can be due to installation errors or ground movement over time. Flexible couplings can accommodate this misalignment, making them particularly useful when installing or repairing a pipe system. Thirdly, the coupling is easy to install. Underground flexible couplings are designed for straightforward installation. They do not typically require any special tools or equipment. This ease of installation can save time and reduce labor costs. When selecting an underground flexible coupling, it is important to consider several factors. Firstly, size is important. Ensure that the coupling is the correct size for the pipe diameter. Using the wrong size coupling can lead to leaks or even failure of the connection. Secondly, material compatibility is also important. The coupling must be made of a material that is compatible with both the pipe and the surrounding environment. For example, if the pipe is carrying corrosive fluids, the coupling must be made of a material that is resistant to corrosion. Similarly, the coupling must be able to withstand the temperature and chemical exposure of the surrounding soil. Underground flexible couplings are available in a variety of sizes and materials to suit different applications. The specific type of coupling will depend on the specific needs of the piping system. It is always best to consult with a qualified professional to determine the best type of coupling for a particular application. To elaborate further on the benefits of using underground flexible couplings, it's helpful to visualize the scenarios where these couplings prove invaluable. Imagine a newly constructed building. Over time, the soil around the foundation settles. This settling can exert stress on underground pipes, particularly those rigidly connected. Without a flexible coupling, this stress could lead to cracks, leaks, and ultimately, costly repairs. The flexible coupling acts as a buffer, absorbing the movement and preventing damage to the piping system. Consider a region prone to frost heave. During the winter months, the ground freezes and expands, putting upward pressure on buried pipes. A rigid pipe system would be vulnerable to this force, potentially leading to breaks. The flexible coupling allows the pipe to move with the ground, mitigating the risk of damage. Another scenario involves the repair of an existing pipe system. Often, when replacing a section of pipe, it's difficult to achieve perfect alignment with the existing pipes. A flexible coupling can bridge the gap and create a secure, leak-proof connection, even when the pipes are not perfectly aligned. Installation of these couplings is typically a simple process. They often involve slip-on connections that are secured with clamps. This eliminates the need for specialized tools or techniques. The ease of installation makes them a popular choice for both professional plumbers and do-it-yourself enthusiasts. When selecting a flexible coupling, it's crucial to consider the specific application and the environment in which it will be used. Factors to consider include the type of fluid being transported, the operating temperature, and the presence of any corrosive substances in the soil. Different materials offer varying degrees of resistance to these factors. For instance, ethylene propylene diene monomer, often abbreviated as EPDM, is known for its excellent resistance to weathering, ozone, and ultraviolet radiation. This makes it a good choice for underground applications where the coupling will be exposed to the elements. Rubber couplings offer good flexibility and are generally less expensive than EPDM couplings. However, they may not be as resistant to certain chemicals or extreme temperatures. The size of the coupling is also critical. It must match the diameter of the pipe to ensure a secure and leak-proof connection. Most manufacturers provide detailed specifications on the sizes and pressure ratings of their couplings. It's important to consult these specifications to select the appropriate coupling for the application. In summary, underground flexible couplings are an essential component for any underground piping system that is subject to ground movement or misalignment. They provide a simple, cost-effective way to protect pipes from damage and ensure long-term reliability. By understanding the benefits, features, and selection criteria for these couplings, you can make informed decisions and ensure the success of the piping project. Now let's delve deeper into the technical aspects of these underground flexible couplings, specifically focusing on their material properties and performance characteristics. The choice of material for these couplings is paramount, as it directly impacts their ability to withstand a harsh underground environment and maintain their flexibility over time. As mentioned earlier, rubber and ethylene propylene diene monomer, often abbreviated as EPDM, are the two most common materials used in these couplings. Let's examine each of these materials in more detail. Rubber couplings are typically made from a synthetic rubber compound that is formulated to provide good flexibility and resistance to abrasion. These couplings are generally more affordable than ethylene propylene diene monomer, often abbreviated as EPDM couplings. However, they may not be as resistant to extreme temperatures, chemicals, or ultraviolet radiation. Rubber couplings are suitable for applications where the soil conditions are relatively mild and the operating temperatures are within a moderate range. Ethylene propylene diene monomer, often abbreviated as EPDM, couplings offer superior performance in demanding environments. This synthetic rubber compound exhibits excellent resistance to weathering, ozone, ultraviolet radiation, and a wide range of chemicals. Ethylene propylene diene monomer, often abbreviated as EPDM, couplings can withstand extreme temperatures, making them suitable for both hot and cold climate applications. Due to their superior performance characteristics, ethylene propylene diene monomer, often abbreviated as EPDM, couplings are often preferred for critical applications where long-term reliability is essential. In addition to the material itself, the design of the coupling also plays a significant role in its performance. Most underground flexible couplings incorporate a series of flexible ribs or bellows that allow the coupling to bend and flex without putting stress on the pipe. These ribs or bellows are typically made from the same material as the coupling body. They are designed to provide maximum flexibility while maintaining the structural integrity of the coupling. The connection between the coupling and the pipe is another critical design element. Most underground flexible couplings use a slip-on connection that is secured with clamps. The clamps are typically made from stainless steel or other corrosion-resistant materials. They are designed to provide a tight, leak-proof seal between the coupling and the pipe. The pressure rating of the coupling is also an important consideration. The pressure rating indicates the maximum pressure that the coupling can withstand without failing. It's important to select a coupling with a pressure rating that is appropriate for the specific application. The manufacturer typically provides detailed specifications on the pressure ratings of their couplings. Installation of underground flexible couplings is generally a straightforward process. However, it's important to follow the manufacturer's instructions carefully to ensure a proper installation. Before installing the coupling, it's important to clean the pipe ends thoroughly to remove any dirt, debris, or corrosion. The coupling should be slid onto the pipe ends until it is fully seated. The clamps should then be tightened to the manufacturer's specified torque. It's important to use a torque wrench to ensure that the clamps are tightened properly. Over-tightening the clamps can damage the coupling or the pipe. Under-tightening the clamps can result in leaks. After the coupling is installed, it's important to inspect it carefully to ensure that there are no leaks. If any leaks are detected, the clamp should be tightened further. If the leaks persist, the coupling may need to be replaced. Underground flexible couplings are available in a wide range of sizes to accommodate different pipe diameters. It's important to select a coupling that is the correct size for the pipe being used. Using a coupling that is too small or too large can result in leaks or even failure of the connection. Most manufacturers provide detailed specifications on the sizes of their couplings. In summary, underground flexible couplings are an essential component for any underground piping system that is subject to ground movement or misalignment. They provide a simple, cost-effective way to protect pipes from damage and ensure long-term reliability. By understanding the material properties, design features, installation procedures, and selection criteria for these couplings, you can make informed decisions and ensure the success of your piping projects. Let's now consider some real-world examples of how underground flexible couplings are used in various applications. These examples will further illustrate the benefits of using these couplings and provide insights into their versatility. In residential plumbing systems, underground flexible couplings are commonly used to connect water and sewer lines to the main supply or drainage system. These couplings are particularly useful in areas where the soil is prone to settling or shifting. They can also be used to connect pipes that are not perfectly aligned due to installation errors or ground movement over time. In commercial buildings, underground flexible couplings are used in a variety of applications, including water supply, fire protection, and wastewater disposal systems. These couplings are often used in areas where the pipes are subject to heavy loads or vibrations. They can also be used to connect pipes that are made from different materials, such as polyvinyl chloride, commonly known as PVC, and copper. In industrial facilities, underground flexible couplings are used in a wide range of applications, including chemical processing, oil and gas production, and manufacturing. These couplings are often used in harsh environments where the pipes are exposed to corrosive chemicals or extreme temperatures. They can also be used to connect pipes that are subject to high pressures or temperatures. In municipal infrastructure projects, underground flexible couplings are used to connect water mains, sewer lines, and storm drains. These couplings are particularly useful in areas where the ground is unstable or where the pipes are subject to heavy traffic loads. They can also be used to connect pipes that are located in difficult-to-reach areas. In agricultural applications, underground flexible couplings are used to connect irrigation lines and drainage systems. These couplings are particularly useful in areas where the soil is sandy or where the pipes are subject to damage from farm equipment. They can also be used to connect pipes that are located in areas that are prone to flooding. In addition to these specific applications, underground flexible couplings are also used in a variety of other situations where pipes are subject to ground movement or misalignment. These couplings are a versatile and reliable solution for protecting pipes from damage and ensuring long-term performance. When selecting an underground flexible coupling for a specific application, it's important to consider the following factors. Firstly, pipe diameter is critical. The coupling must be the correct size for the pipe being used. Using a coupling that is too small or too large can result in leaks or even failure of the connection. Secondly, material compatibility is important. The coupling must be made of a material that is compatible with the pipe and the surrounding environment. For example, if the pipe is carrying corrosive chemicals, the coupling must be made of a material that is resistant to corrosion. Thirdly, pressure rating needs consideration. The coupling must have a pressure rating that is appropriate for the specific application. Using a coupling with a pressure rating that is too low can result in failure of the connection. Lastly, temperature range has consideration. The coupling must be able to withstand the operating temperatures of the application. Using a coupling that is not rated for the operating temperatures can result in damage to the coupling or failure of the connection. By considering these factors, you can select an underground flexible coupling that is appropriate for the specific application and ensure long-term reliability. Furthermore, let's explore some best practices for maintaining underground flexible couplings to prolong their lifespan and ensure optimal performance. Regular inspection is key to identifying potential problems early on. Schedule routine inspections of the couplings, especially in areas known for ground movement or exposure to harsh conditions. Look for signs of wear and tear, such as cracks, abrasions, or deformation of the coupling material. Also, check the clamps for corrosion or loosening. Address any issues promptly to prevent further damage. Proper installation is crucial for the long-term performance of underground flexible couplings. Ensure that the couplings are installed according to the manufacturer's instructions. Use a torque wrench to tighten the clamps to the specified torque. Avoid over-tightening or under-tightening the clamps, as this can damage the coupling or compromise the seal. Protecting couplings from physical damage can extend their lifespan. Shield the couplings from direct impact or abrasion from rocks, debris, or heavy equipment. Consider using protective sleeves or wraps to provide an additional layer of protection. Preventing exposure to harmful chemicals is also important. If the couplings are exposed to corrosive chemicals, take steps to minimize exposure. Use chemical-resistant coatings or barriers to protect the coupling material. Regular cleaning can help remove dirt, debris, and other contaminants that can accumulate on the coupling surface. Use a mild detergent and water to clean the couplings. Avoid using harsh chemicals or abrasive cleaners, as these can damage the coupling material. Monitoring ground conditions can help identify potential problems that could affect the couplings. Keep an eye on soil settling, frost heave, or other ground movement in the area. If you notice any significant changes, consult with a qualified professional to assess the potential impact on the piping system and the couplings. Keeping records of inspections, maintenance, and repairs can help track the performance of the couplings over time. This information can be valuable for identifying trends and making informed decisions about future maintenance or replacement. When replacing underground flexible couplings, choose high-quality replacements that are specifically designed for the application. Consider the factors discussed earlier, such as pipe diameter, material compatibility, pressure rating, and temperature range. By following these best practices, you can maximize the lifespan and performance of underground flexible couplings and ensure the long-term reliability of the piping system. Now, let's discuss some common troubleshooting scenarios involving underground flexible couplings and provide practical solutions to address these issues. Leakage is a common problem that can occur with underground flexible couplings. If you detect a leak, first check the clamps to ensure that they are properly tightened. Use a torque wrench to tighten the clamps to the manufacturer's specified torque. If the leak persists, the coupling may be damaged and need to be replaced. Misalignment can also cause problems with underground flexible couplings. If the pipes are significantly misaligned, the coupling may be unable to provide a proper seal. In this case, you may need to realign the pipes or use a longer or more flexible coupling. Corrosion can also affect the performance of underground flexible couplings. If the couplings are exposed to corrosive chemicals or soil conditions, they may corrode over time. Inspect the couplings regularly for signs of corrosion. If corrosion is detected, the couplings should be replaced. Damage from external forces can also occur. Underground flexible couplings can be damaged by rocks, debris, or heavy equipment. Protect the couplings from physical damage by using protective sleeves or wraps. If the couplings are damaged, they should be replaced. Premature failure of couplings can occur. If underground flexible couplings are failing prematurely, there may be an underlying problem with the piping system. Consult with a qualified professional to assess the system and identify any potential issues. Compatibility issues can arise. Ensure that the coupling is compatible with the pipe material and the surrounding environment. Using an incompatible coupling can result in premature failure. Incorrect installation can also cause problems. Ensure that the couplings are installed according to the manufacturer's instructions. Incorrect installation can result in leaks or premature failure. By understanding these common troubleshooting scenarios and implementing the recommended solutions, you can effectively address issues with underground flexible couplings and ensure the long-term reliability of your piping system. Also, let's explore the relevant industry standards and codes that govern the use of underground flexible couplings. These standards and codes provide guidance on the design, installation, and performance of these couplings, ensuring safety and reliability. The American Society for Testing and Materials, often abbreviated as ASTM, is a globally recognized organization that develops and publishes voluntary consensus standards for a wide range of materials, products, systems, and services. There are several American Society for Testing and Materials, often abbreviated as ASTM, standards that are relevant to underground flexible couplings, including American Society for Testing and Materials, often abbreviated as ASTM D5926, which covers flexible transition couplings for underground piping systems. This standard specifies the requirements for flexible transition couplings used to connect different types of piping materials in underground applications. It includes requirements for materials, dimensions, performance, and marking. American Society for Testing and Materials, often abbreviated as ASTM, F2934 covers polyethylene plastic pipe and fittings for water service and yard piping. This standard specifies the requirements for polyethylene plastic pipe and fittings used in water service and yard piping applications. It includes requirements for materials, dimensions, performance, and marking. The Uniform Plumbing Code, often abbreviated as UPC, is a model code that is widely adopted by states and municipalities in the United States. The Uniform Plumbing Code, often abbreviated as UPC, provides requirements for the design, installation, and maintenance of plumbing systems, including underground piping systems. The Uniform Plumbing Code, often abbreviated as UPC, references American Society for Testing and Materials, often abbreviated as ASTM, standards for various plumbing materials and components, including underground flexible couplings. The International Plumbing Code, often abbreviated as IPC, is another model code that is widely adopted in the United States and other countries. The International Plumbing Code, often abbreviated as IPC, provides requirements for the design, installation, and maintenance of plumbing systems, including underground piping systems. Similar to the Uniform Plumbing Code, often abbreviated as UPC, the International Plumbing Code, often abbreviated as IPC, references American Society for Testing and Materials, often abbreviated as ASTM, standards for various plumbing materials and components, including underground flexible couplings. Local plumbing codes are also important to consider. In addition to the national model codes, many states and municipalities have their own plumbing codes that may be more stringent or have specific requirements for underground piping systems. It's important to check with the local authorities to ensure that you are complying with all applicable codes and regulations. These codes often refer to tables within the National Electrical Code. As for electrical installations, the National Electrical Code, often abbreviated as NEC, does not specifically address underground flexible couplings for plumbing systems. The National Electrical Code, often abbreviated as NEC, primarily focuses on electrical wiring and equipment. However, if the plumbing system is located in close proximity to electrical equipment, it's important to ensure that the installation complies with all applicable electrical safety requirements. Always consult with a qualified professional to ensure that the installation is safe and compliant with all applicable codes and regulations. By adhering to these industry standards and codes, you can ensure that your underground flexible coupling installations are safe, reliable, and compliant with all applicable regulations. These standards provide a framework for ensuring the quality and performance of these couplings, protecting both property and public health.